Hi! In this video we will sort a list of numbers using counting sort. Counting sort does not use comparisons, but instead it uses statistical tools to achieve its goal. More particularly, it builds a histogram of the input elements and then creates a mapping from the input list to the sorted output and then uses that map to generate its output. This way, we will not be bound by the limit of comparisons, but instead the limit of building the histogram. Depending on the input and the environment, this exchange of compute to memory may be a good alternative. Okay, let's start typing. First, I create a copy of the numbers variable that we will use for the rest of this code. And then we can start building the histogram. In order to be able to build a histogram, we will need to be able to address all the elements in an array that we have in the input. To be able to do that dynamically, we will need to find the biggest number in the input list. I will call that k and use the max function to find it. We will also need to add 1 because we are going to use it as an array address. And now we are ready to allocate our histogram array, which is going to be of zeros of k length. Now I can go through the elements in the array and just increment the eth index by 1 for each of these elements. Now let's print the histogram. Histogram is going to be count. Now we can run this, and here we go. For each element we have a 1 in this array, and we have one number 3, one number 4, one number 5, we don't have a 6, we have a 7, and we have an 8. This is the meaning of this list of numbers. Now, using this, we should be building our mapping to the output. This is going to be a simple prefix sum, which is basically just the summary of the current element and the previous element, and it will make sense as soon as we are able to print it. For this, we need to go through the indexes of the count array, and for each element this is going to be the summary of the current element and the previous element, and this is going to be our index map. Let's take a look at this as well. Index map. Now it is going to be in the count array, and now if we take a look, we can see number 3 will go to the first index of the output, number 4 will go to the second index of the output, and so on. You see there's no 6, there's no increment here, 6 will not go anywhere, and that makes sense too. Now, having this mapping, we can start generating our output. The output will need a fresh array. I will call this output and initialize it with the zeros of the length of the input array. And then we can go through the array and use our mapping. The first thing to do is to decrement the count. This is necessary if we have multiples of the same exact element. Let's say we have 2 number 3s in the input or something like that. It would keep the indexes correct in those cases. We don't have that right now, but we still do it anyways. So now we can write the output, which is just going to be the index of count e equals to e. Let's also add a message for this so that it becomes more meaningful what we are doing. We are putting e to index count e. And when this loop finishes, we are ready with our sorted output. And we could return it if we were building a function. So let's turn this code into a function. It's going to be counting sort array. And now we are ready to call it. It returns a new array, so I will create a new variable for holding the sorted result. Counting sort numbers, and let's print the final results. Sorted is sorted array. And as we can see, let's see the total output. So we have the histogram, the index map, and we are executing the index, and we get our sorted array at the end. That is it. Thank you very much for watching, and see you in the next one.